ever find yourself, kind of lost in thought about just how amazing our brains are, like how we process the world, control every little movement, even experience all those complex emotions?
Right. It's wild.
It really is. And today we're diving deep, like really deep, into one of the brain's most fascinating secrets, neurotransmitters, those chemical messengers that make everything happen.
Of how our brains communicate, constantly relaying critical information between like billions of neurons.
So it's like a superhighway of signals constantly zipping around in there, dictating everything we do, think, and feel.
Exactly. They're behind everything, every thought, every action, even every emotion.
Wow. That's pretty profound when you think about it. So like, where do we even begin to unravel this?
Well, to really understand the brain, especially when it comes to mental health or how medications work, we need to understand these neurotransmitters.
Makes sense. Okay, so let's meet some of these powerful chemical messengers. What's like the first one that comes to mind?
Well, acetylcholine is a good place to start. It's pretty famous for its role in, well, every time we move a muscle.
Oh, right. So no acetylcholine, no morning jog?
Pretty much. But it's not just about movement. It plays a huge role in memory, too.
Really? How so?
Researchers figured out that if you block acetylcholine activity, it becomes really hard to form new memories.
Wow. So without it, every experience would just be fleeting. We couldn't hold on to any of it.
Exactly. Kind of makes you appreciate just how important balance is in this system, right?
For sure. Okay, so we've got acetylcholine, but what about dopamine? Isn't that the feel-good neurotransmitter, the one that gives us that rush of pleasure?
Exactly. Every time we experience something pleasurable, whether it's a delicious meal, acing a test, or those little wins throughout the day, dopamine is there.
So dopamine is basically the driving force behind our motivation and that sense of reward, but I also know it's closely linked to addiction.
Yeah, it's kind of a double-edged sword. When we do something enjoyable, our brain rewards us with this dopamine rush. But think about addictive substances. They kind of hijack that pathway, leading to cravings and that relentless pursuit of another dopamine hit.
It's like the brain gets fixated on chasing that reward signal no matter the cost. That's fascinating and scary all at the same time. But dopamine isn't just about pleasure and addiction, though, right? I read something about its connection to movement, too.
You're right. It actually plays a key role in movement. In Parkinson's disease, for instance, the dopamine-producing cells in the brain start to die off. That's what leads to the tremors, stiffness, and difficulty with, just moving normally.
It's amazing how one tiny chemical can have such a widespread impact.
It really is.
Okay, so we've got the mover, acetylcholine, the motivator, dopamine. What about the one that keeps things running smoothly, keeps us feeling balanced?
Ah, you're talking about serotonin, often called the mood stabilizer. And here's a fun fact. What we eat can actually impact our serotonin levels.
Wait, really? So there's truth to you are what you eat, at least when it comes to serotonin.
Absolutely. Our gut and our brain are in constant communication.
Yeah.
And the foods we consume can definitely influence those serotonin levels.
It's like giving our brains the raw ingredients for happiness, or, well, at least contentment.
Exactly. Foods rich in tryptophan, which our bodies convert into serotonin. Those are the ones that have been linked to a more positive mood.
Okay, got it. Load up on the tryptophan. So we've covered acetylcholine, dopamine, serotonin. Are there any other key players in this chemical orchestra we should know about?
Oh, definitely. We can't forget about glutamate and GABA. Those are essential too. Think of them like the brain's on and off switches.
The on and off switches. Okay, now you have to tell me more about this dynamic duo and how they help keep our brains in check.
So glutamate, that's our primary excitatory neurotransmitter. It's like stepping on the gas, making those neurons fire and send signals all over the place.
And that's
But if we have too much glutamate, it's like an overstimulated brain, and that can lead to problems.
Ah, so that's where GABA comes in, hitting the brakes.
Exactly. Out of control. It helps us relax and prevents overexcitation.
So it's this constant interplay, this delicate dance between glutamate and GABA that keeps everything functioning smoothly.
Precisely. A constant balancing act between excitation and inhibition. And when it's working right, we don't even realize it. But when it's off, that's when things can feel, well, off.
It's amazing how much complexity is packed into those tiny chemical messengers, right? Like a perfectly choreographed ballet happening in our brains every second of every day. But knowing that these neurotransmitters are so crucial for just about everything we do, I'm particularly curious about their role in something that affects so many people,
Yeah.
mental health. So how do these neurotransmitters, these chemical messengers actually play into mental health? I mean, we always hear about imbalances and things like that, but is it really that simple?
It'd be nice if it were that straightforward, right?
Yeah.
But the reality is it's way more complex than that.
Figures.
Mental health, it's like this incredibly intricate web, influenced by so many things: our genes, our environment, our life experiences, even, the bacteria in our gut play a role. Neurotransmitter imbalances, they're definitely part of the picture, but it's not as simple as saying low serotonin equals depression.
Right. It's not like flipping a switch.
Exactly.
So, how can we even begin to understand the role these neurotransmitters play when there are all these other factors at work?
Well, it's about understanding the interplay between all these different elements. Think of it like, I don't know, an ecosystem.
Okay, I like that.
You've got all of these different organisms, right, all interacting with each other. And if one population explodes or gets wiped out, it throws the whole system out of whack.
Makes sense. So how does that ecosystem analogy play out in a specific condition, say like generalized anxiety disorder?
Well, in GAD, some research suggests there might be an imbalance between, remember we talked about glutamate and GABA, the brain's on and off switches?
Yeah, the ones that keep our brains from going haywire.
Exactly. So if there's either too much glutamate or not enough GABA, it can create this state of overexcitation in the brain.
So the brain's stuck on overdrive and can't find the off switch.
Pretty much. And that can lead to, those persistent feelings of worry, nervousness, that kind of constant apprehension that people with GAD experience.
It makes you realize just how delicate this whole system is.
Right. That's a balancing act for sure.
But the good news is we're starting to understand these mechanisms, and that's led to the development of medications that can actually target these neurotransmitter systems.
Exactly. And that's where our discussion of agonists and antagonists comes in.
Ah, right. Those medications that act like either the key or the decoy to those neurotransmitter locks. But how do they really work to, actually bring about those therapeutic effects? Let's unpack that.
It really is amazing when you think about it, how we can use medications to fine-tune these intricate processes in the brain.
Right. We're talking about targeting these microscopic mechanisms to bring about real changes in how we feel and function.
Exactly. And a lot of these psychiatric medications, they work by either mimicking or blocking the actions of specific neurotransmitters, trying to restore that balance we've been talking about.
Right, like with those agonists and antagonists acting as the key or the decoy to those neurotransmitter locks. But what does that actually look like in practice, on a chemical level?
Okay, so let's take SSRIs as an example. Those are a type of antidepressant that specifically target serotonin.
Which we talked about earlier, right? The mood stabilizer.
Yep, that's the one. So picture this. Serotonin gets released from one neuron, right? And it's floating in the synapse, ready to bind to receptors on the next neuron. But normally, it gets reabsorbed pretty quickly, which limits its effects.
So it's like a revolving door, constantly cycling through, but not really sticking around.
Perfect analogy. That's exactly what it's like. But here's where SSRIs come in. They actually slow down that revolving door.
So they prevent the serotonin from being reabsorbed so quickly.
Exactly. And that means more serotonin is available in the synapse, which can help boost those mood-regulating signals.
Like giving those positive vibes a little extra staying power.
Exactly. And then you have medications like benzodiazepines, which are often used to treat anxiety. They work a little differently by enhancing the effects of GABA.
GABA, that's the one that calms everything down, right? Our brain's built-in chill pill.
That's the one. So benzodiazepines actually bind to specific receptors on GABA neurons, which makes those neurons more receptive to GABA's calming effects.
So it's like they give GABA a boost, amplifying its ability to quiet those anxious thoughts.
Exactly. And it's through these incredibly intricate interactions, these delicate chemical dances, that medications can actually help restore balance and alleviate some of those really tough symptoms people experience.
It really is remarkable when you think about it. I mean, we've gone from having a very basic understanding of the brain to being able to pinpoint these microscopic processes and develop these targeted therapies.
It speaks volumes about how far scientific research has come, for sure.
It really does. And to think we're only just scratching the surface of what there is to know about the brain. Who knows what incredible discoveries are still to come?
Who knows, indeed. There's so much more to explore, which is what makes this field so exciting.
Absolutely. Well, on that note, I think we've covered a lot of ground today. Huge thanks to expert speaker for walking us through this incredible world of neurotransmitters. And for all of you listening, thank you for joining us on this deep dive. Remember, the more we understand about our brains, the more empowered we become to take charge of our health and well-being. Until next time, keep those brains buzzing.